everybody, welcome back. We're going to do some special cases. I want you to go ahead and try to graph this on your piece of graph paper. Again, if you don't have graph paper, there are links next to this on the next to this assignment on your home page that will get you a copy of a piece of graph paper, and then you can print it out and use it for your own graph paper. So hopefully you've tried to graph it, and I'm going to go straight to this. Again, I'm already happy because both of these equations are written in the form of slope-intercept form, y equals mx plus b. Remember the sign's being changed with an inequality sign now. That means that because these are already in that form, I just have to identify what my begin is and what my move is for each one of these inequalities. So let's start with the first one. The first one, oops, I didn't want that, I wanted this. That first one, my begin, I have to start with the begin because that's my y-intercept and that's where I start. It's 2. And that means it's the point 0, 2. And then m, or my slope or move, is 3/4. And so on this first equation, I'm going to begin at 2, 0, 2. That's the point, that's my begin. And my move is going to be rise up 3, run 4, rise up 3, run 4, and next one won't fit. The opposite of 3 is -3, opposite of 4 is -4, so I'm going to go down 3, -4, down 3, -4, right? And now, before I do anything, I got to check. Is my inequality included or not? Well, this is a less than or equal to sign, so that means that the line is included in the answer. So this is the line that's included. And now I check. Is the y being having a mouse pointing towards it or a gator? This is definitely a mouse facing towards that y, so a mouse is less than. That's the side I can't skate, so here's my dude. He's like, hey, this side I can skate, but this side, come on, buddy. Work with me, buddy. Whoa! My gosh, that was starting at 2. He's being very resistant. But on this side, you can't walk, so he's gone, right? So this is the side that I can't skate on, so I'm going to shade on this side. All right, that's done. Next, I'm going to take this inequality up and take care of the second inequality. So I'm going to erase these so you have room to see, and I'm bringing down the second inequality. And again, I start off and say, oh, it's already in slope-intercept form, so I just need to find my begin. My begin seems to be -3. And my move, begin is -3, and my move is 3/4. So that means, again, this is the point 0, -3. So I'm going to begin this equation, and I'll make this green. I'm going to begin at -3. That's 0, -3. That's right there. And my move is up 3 over 4. And this is up 3 over 4, up 3, and won't fit in there. The opposite would be down 3 over 4, down 3 over, get it in there, come on, get in there, graph. Down 3 over 4. And I'll make this the whole page. It'll be shrink it up a little bit, but at least we'll be able to see it. And then I check, is this included? And the answer is it's not, because it doesn't have an equal sign, so this must mean that this boundary, oops, I'll try to make that line a little bit better. Maybe this will be against me. This boundary, up 3 over 4. So this boundary will be a dotted line. And then I check, is there a mouse or a mouth facing, or a gator facing towards the y? It's a gator. Gator means greater, which means I'm graphing above the line. And so you end up with this weird thing where the two lines don't actually intersect, and that doesn't happen very often. But what it means is it means that the solution to this system is right here in the middle area. This is where the solution to this system is. It's right in the middle. It's because the two lines are parallel. And because they never cross, but usually if this had been just a system of equations, we'd say no solution. But because they're parallel and they shade in opposite directions of each other, we do have a solution. So you can have parallel lines and still have a solution. So my solutions would be anything in here like 0, 0 is a solution. 10, 8 is a solution, -2 is a solution. some areas that are not solution, anything in this area, like negative 10, 10, and some not solutions are also over here, negative 10, 10, negative 10. So solutions are in the middle area here. It's a special case only because the two lines are parallel. Okay, so next one. Here's another special case. Again, this one is already in slope-intercept form, so I'm going to kind of go really fast here. Hopefully you have tried to graph this on a piece of paper. Y equals mx plus b is what I'm going for. And so I'm going begin and move. My begin is 2. My move is negative 2, which is negative 2 over 1. And this is the point 0, comma 2. And I'm going to graph it, 0, 2. And my slope is going to be down 2, positive 1, down 2, positive 1, because my slope is negative. It should be in a negative direction. And the opposite of that is going to be 2 over negative 1. So I'm up 2, negative 1. And I check, is this included or not included? It looks like it's included. So that means the line is part of the answer. And then I look at it and say, is there a mouse or a gator facing towards that y? And it's a gator, and a gator is greater, so that's going to be facing this side. So I graph, life is good. That one's done. Okay, now we got to graph the second one. The second one is not in slope-intercept form. So the first thing I need to do is make this graph look like this, with y by itself. In order to do that, I'm going to circle the inequality sign, then I'll circle the variable I'm solving for. The coefficient is 1, so I don't need to worry about it. But I do need to get rid of that constant. So I'm going to subtract 2x from both sides. Or I did one side, I have to do the other. 2x minus 2x is 0. Gives me y. Negative 4 minus 2x, they're not like terms, but I want to put the x first because the slope comes first. And we put variables before constants. And then finally, I look at the sign. Did I multiply or divide by negative? I did not. So the sign stays the same. So now all I got to do is put my begin and my move. I began at negative 4, and my move is negative 2 over 1. So I'm going to graph this in green, and I'll say I'm beginning at negative 4, 1, 2, 3, 4, and I'm moving down 2 over 1. Down 2 over 1. Down 2 over 1. And the opposite is up 2, negative 1, up 2, negative 1, up 2, negative 1. And all the way up. And again, I check, is this part of the solution? It doesn't have an equal sign, so this will be a dotted line. That means the boundary is not included. And then I ask myself, does the y have a mouse or a gator facing towards it? It has a mouse, that means it's less than, so we shade beneath it. And we look and say, wait a second, these never overlap. So what happened here is we have a parallel line this time, but because they shade in opposite of each other, not through each other, there is no area where there is a solution. So this would be a no solutions. And the reason why it's no solutions is, as you can see, there's no place where I can put a point that will be in both areas at the same time, or shaded in both areas. So this is called the no solution. If you have parallel lines and they don't shade towards each other, then that's no solutions. If you have parallel lines and they do shade, it's just parallel lines. And so the answer is where they overlap. So hopefully you can do that. Just know that if you see that, a parallel line, then it's no solutions. Okay, thanks.